So as part of the final learning design, I'm also trying to give you a little bit of an ontology of what you'll be doing. So you don't always have to read these, but I know that it works for some students depending upon your style. So just to review this one here, hey, it looks like I'm going to load an Excel file to a DF. Oh, I need to remember that's a data frame. I'm going to look at the rows, columns, data types. Oh, then what am I going to do? Well, I'm going to reshape it. So I'm going to use this feature called data frame to dictionary, and then I'm going to be able to slice the data. And so that's what we just saw up top. Oh, but the last part is now I'm going to work with a class ontology. So what am I going to do? Well, I'm going to compute a summary and I'm going to store results. So you're going to have to learn what the behaviors are, and then you're going to simulate it, and you're going to simulate it against summing it, going to my list to do some recording, and then it's going to give you a final outcome, which in this case was how many plays did you actually read. So one thing to keep in mind, if I haven't said it in a while, is that whoever's in the code book, remember, usually you'll save it to your machine. You can work with it here, but if you do that, you want to make sure you're always running it. So even if you see something that I've run, it doesn't mean that it has run. So I'm trying to also give you searchable ways that you can do file search. So if you were to do edit search, it can help you move around the code book. So remember that type of thing too, because I'm trying to help you out. So, well, hey, boom, here you are. I've created a class. All right, and I just call it the Shakespeare's minion. Well, that means it's the parent object, and it's defining it by, oh, well, it has a name, and that's the name, whatever name you give it. And in this case, it has these variables like I'm going to perform some work, I'm going to read some plays, I'm going to have the plays that I don't read, and the number of plays that I'm doing now. So these are collectively a computation feature. So the self is the class self has these categories, and one category is equal to another category. Total plays not read equals total plays. So you might sit there and go, oh, well, this is when you kind of need to be like, oh, well, I've got 37 plays. All right, well, now it looks like, well, oh, look at this. I have a new feature called input. So it's an interactive module, and it's going to be asking you how many plays would you like to read. And then it is using this if-then, which I ask you to come and try and figure out. If you put in 0, well, the function ends. But otherwise, how many plays you're going to read, and it'll ask you how many plays you want to read. Then it's going to report on how many plays was worked on. So it has this weird little queuing feature in here, and it's not set to any time. Okay, so usually these type of things would then be all this other code of like how much time does it take, or if I'm going to calculate, landing a spaceship. I mean, it can be all of those type of things really that quickly. So it is essentially whatever your computation method is. But I designed it this way so you can see a basic if-then, and then with how the variables are getting incremented or decremented. So we have minus equal 1 or plus equal 1 of how much of the units of work are getting done. So it's only one simple thing is being done, whereas if we were like calculating volumes of water, you'd be like, whoa, I got to learn all that. So that's why I'm trying to bring this back around to what is the basic structure. So the end of this is that it sums up what the total batch work was done, and then it returns you the outcome of that batch work. All right, and it uses a few little weird things like str. You're like, what's that? Oh, well, it's a string, and so it makes sure that it provides you a string output, and as opposed to if you would put integer int as opposed to putting real. So I'm not asking you to learn all these names, but a part of your job in intro to programming is recognize, well, that's a function, and sometimes if you were to click on it, depending upon the IDE, and it'll automatically come up and tell you what it is. So the way Google Colab does that is you would actually use the AI and ask it. Anyway, but the last two sections are then, I got to create the child. Remember, that's the parent up top. That's the parent. Now you got the child. My minion is going to equal Shakespeare minion. And then the minion's going to go and calculate how much work. And then the last section, 9.2.3, is then describing what work was done. So I'm going to leave that for you to figure out, and I have some simple questions for you to answer. But this completes the basic structure on classes, which will then allow you to build some simple classes of your own. Because usually you get a lot of programmers who put everything in a class to go and do the work that you want, as opposed to just writing root lines of code. And then when you get a really good class that you like, that's when it becomes the parent object. All right, so still don't get hung up between an object and a class. A class, it can equal an actual object, or it will be something that you constructed. So it's really just that simple. So I really appreciate your time. I know this video was a little long, but I'm really excited for all of you, and I'm going to be finishing off recursion and sending that out very shortly. All right, take care.